Hi everyone, this is Kevin Lewitsky. I'm in Group 19 in Engineering Design 1 at FAU, and this is our submission for the Fall 2019 mini project. For the mini project, we put together a basic security system. It's running on a Raspberry Pi 3B Plus, and connected to it are a motion sensor, which is here, and the camera, which is here. The motion sensor is an Adafruit brand motion sensor, and the camera is a Dorhea camera for the Raspberry Pi 4 or 3B Plus, and I'll put the model numbers and link to both of those items in the description of this video. Also connected to the Raspberry Pi board is the LED light, which is right here. The basic premise is that there's a Python program running, and every 5 seconds it checks to see whether there's motion detected or not. And if there is motion detected, then the LED light turns on and the camera captures an image and stores it in a folder. And it does that every 5 seconds. If motion is not detected, then an image is not captured and the LED light is turned off. The camera is connected to the Raspberry Pi through this white ribbon cable here, and it's connected to the camera port, which is right here. The motion sensor and the LED light are both connected to what's called the GPIO, or general purpose input-output pins, which are here. These pins are numbered 1 through 40. The lower number pins are on this side of the board, the higher number pins are on this side of the board, and the even numbered pins are on the outside line of pins, and the odd number pins are on the inside line of pins, closer to the center of the board. Pin number 2 is a 5-volt output pin, and pin number 6 is the ground pin. So pin 6 is this pin that has the black wire connected to it, and pin 2 is the pin that has this red wire connected to it. And those are both connected to the high voltage and ground lines on the breadboard. And then the motion sensor, in addition to being connected to those high and low lines on the breadboard, is also connected to pin 11. And that pin 11 is configured as an input pin, meaning that that Python program is able to detect whether that motion sensor is sending a high or low signal to pin 11, and if it's sending a high signal, then it knows that at that point in time motion is detected, and if it detects a low signal on pin 11, then it knows at that point in time that motion is not detected. And pin 3 is configured as an output pin, and it's sending voltage to the LED light here. So the Python program, at the same time that it's detecting motion, if motion's detected, then it's sending voltage through pin 3 to the LED light. And then that LED light is also connected to the ground line on the breadboard. In the next section of the video, I'll demonstrate the Android app. We've written an Android app that is able to connect to the Raspberry Pi and display the images that have been captured. The Raspberry Pi is running an Apache web server, and the Android app is connecting to the Raspberry Pi via the Wi-Fi network. So the Raspberry Pi has a Wi-Fi adapter built into it, and right now it's connected to my router at home. And my cell phone, which is a Samsung Galaxy, is running the Android app that we wrote, and that's also connected to the Wi-Fi network. And so it is connecting to the Raspberry Pi using the host name of the Raspberry Pi. It's getting those images that have been captured, and it's displaying those in the Android app. The Android app also has a button to delete all the images, so whenever the user clicks that button, it sends an HTTP GET request to the Apache web server, and we have a PHP file that receives that request, and then it deletes all the images that have been captured. So in essence, what's happening is the Raspberry Pi is running a Python program, and it's detecting motion. Whenever motion is detected, every 5 seconds it captures an image. It's storing those into a folder that's then, the images are displayed or accessible from the Android app via that Apache web server, where the user can view the images and then delete the images once they've viewed them. So in the next section of the video, I'll demonstrate the Android app, and then at the end of the presentation, I'll show you some of the code that we've written that makes all of this work. In this part of the video, I'll demonstrate the Android app. So right now I've got the security system set up here on the table, and I've got the camera facing a wall. And this is the phone that's running the Android app. So what I'll do is I'll restart the app so that you can see what happens when the app starts. It'll display a toast message at the bottom of the app that says connected to Raspberry Pi-GRP19. That's that message there. And the same message is displayed here at the top of the screen. You can see here it says no images to display because the Raspberry Pi security system hasn't taken any images since the app started. So what's happening is the phone and the Raspberry Pi are both connected to the same Wi-Fi network, and the Android app is looking for the host name Raspberry Pi-GRP19. And since the Raspberry Pi is running that Apache web server, the Android app is able to display on the screen whatever images are being served by that web server. So what I'll do is I'll demonstrate that the motion sensor works and that it captures an image. I'll go stand in front of it and you'll see my picture taken. So when I click the refresh button here, you can see a few pictures were taken. This was one as I was walking towards the wall. I stood in front of it so that you could see me there. And then this one was taken as I was walking away from the wall. Each image is timestamped, so you can see here it says, they all say October 26, 2019, 8:40 p.m. This one was taken at 42 seconds. This one was taken at 48 seconds. And this one was taken at 53 seconds. If you click on one of the pictures, you can actually see it opens up in a separate page in a web browser, so that if you click on it, you can download the image if you wanted to save it. I'll go back to the app now, and what I'll do is I'll click delete all images, and it says 4 images deleted. So what that means is that since we were looking at the app, the motion sensor picked up some motion for me. It actually captured a 4th image. I'll click refresh. You can see it says no images to display. So that means that all the images were successfully deleted and there's no more images stored on the Raspberry Pi. And every time that delete all images button is pressed, the Android app sends an HTTP GET request to the Apache web server, and the Apache web server that's on the Raspberry Pi is processing that request using a PHP file. So that PHP file processes the request, it deletes the images, and then it sends a success message back to the Android app. In this part of the video, I want to show the code that's used to run the Python program that's running on the Raspberry Pi, and also the code that was used to write the Android app. So right now we're looking at the desktop of the Raspberry Pi, and this is the Python program. It's a very basic program. As you can see, when the program starts, we set up pin 3, the GPIO pin 3 as an output pin to control the LED light, and we set up pin 11 as an input pin, which is used to determine whether the motion sensor is detecting motion or not. And then we're going to execute this while true loop, so this loop executes indefinitely, and we're going to check whether the input pin 11 is high or low, and if it's high, that means that I is true. We're going to turn on the LED light here, which is on pin 3, and we're going to capture an image with the camera and store it at this location, which is accessible from the Apache web server, and that image file name has a timestamp with it. And if the input pin 11 is low, that means that motion is not detected. We'll execute this part of the loop here, which basically turns off the LED light. We'll wait 5 seconds, and then we'll repeat this loop again, and that loop continuously repeats until the program is stopped by turning off the Raspberry Pi. And this is the code in the mainActivity.java file for the Android app. So when the app starts, we're going to send a request with the volley library to this address here. This is the host name for the Apache web server that's running on the Raspberry Pi. If we're able to connect to the Raspberry Pi, you can see here we're going to set the text in the app that says, it'll say connected to Raspberry Pi-GRP19, and we'll also display the toast message here. And if we're not able to connect to the Raspberry Pi, then we'll display the message not connected to device. And we know that we're not connected if we send that request using the volley library to this address here and we don't get a response. Then we know we're not connected in that case. We also set up on-click listeners on the 2 buttons that are in the app. One of the on-click listeners is for the delete all images button. So whenever the user clicks that button, we'll send a request to a PHP file which is located at this address here. And when we get a response back from that PHP file, then we'll display the toast message that all images have been deleted. And if we don't get a response back from that PHP file, then we'll display the message here, unable to delete images. And finally, we have an on-click listener on the refresh button. And what that does is that simply reloads the web view that displays the images that are being served by the Apache web server. And here in the center of the screen is the PHP file that's on the Raspberry Pi. And this PHP file is executed by the Apache web server whenever it gets a request for this delete_images.php file from the Android app. And so what we do is we take all of the images that were captured by the camera and stored in the images directory, which is underneath the location for this delete_images.php file. We declare a variable here called count, and then those images are loaded into an array called files, and we simply loop through that array. We check for each of the files. We first check, is that file a good file? If it is, then we, in Linux, we change the permissions to 777, which allows this delete_images.php file to modify the file, to write to the file. Then we use this unlink to delete the file, and we increment the counter. And then finally, we send back the message to the Android app that the images were successfully deleted.